So we already learned how to solve a system of equations through graphing and substitution. Now we're going to focus on elimination. And elimination is basically combining two equations to the point where one of them gets eliminated. So let's get started on this one. Just skip the intro and going straight into our objective. As always, guys, what I recommend doing is looking at the guided notes, especially because they do give you a video on how to solve by elimination. So if you want to see more on the technique, this is a really good way to learn how to do it, is watching the video. Guided notes is a good way of kind of knowing all the steps and how to do everything. So those resources are there for you. And I forgot to read the objective. The objective, I feel like Edmentum kind of goes into obvious territory. It's like we're going to solve using elimination. So let's go into the introduction. So let's do our warm-up exercise. The sum of two positive numbers is 37. So this is just saying that we have two numbers that are positive. So we're going to add two numbers that are positive, and it's going to give us 37. Their difference is 7. So in other words, x minus y is equal to 7. If the numbers are unknown, which two equations would solve for? So I did these. We're just adding them together, and we got 37. So we're definitely going to get this one, and we're going to get this one. So those are two equations that we're going to be using. So that was a quick little summary of just how to understand how to do this. X and Y are unknown numbers. Let me just erase this. All right, so now we're going to figure out how to solve this. So if we look here, X and Y are kind of negative. So if we added them together, what happens is that Y cancels out. So there's two ways of doing it: by simply adding, and there's going to be some times where we subtract. But since they're already negative, it's like might as well add them together. From here, we'll just divide. Now that we know what x is, we'll be able to solve for y. So we can just plug in this x into either equation. They chose to plug into the first one, but there's nothing stopping you from plugging into the second equation. So you do have a choice here when you're solving. All right, so solving through elimination method. So now we're going to actually do the process. So if we look at these, we can't really just add it like we did with that last one. What we're going to have to do here is we're going to have to choose one. So you have to choose, am I going to eliminate x, or am I going to eliminate y? So you have to pick which one you're going to eliminate. Edmentum is choosing to eliminate y. And this is easy because of the fact that all you have to do to get rid of it, to make these two the same, is just multiply this y by 5. But in math, you can't just multiply only this by 5. You have to multiply everything. You have to multiply both sides. This is something we did when we were just solving for one variable. So if you want to do something to one side, you have to do it to the other. You can't just do it to y either. You have to do it to all this side. So when we're doing elimination, you have to use multiplication to be able to eliminate them. So we multiply everything out, we get this brand new equation that is, if we distribute this, so if I just take this 5 and distribute it, technically you're distributing it to the 12, but they just wrote it again. I like writing my equations like this to show them doing it for everything, but they kind of showed it separately. So from here, we get this 10 plus 5y. From here, we're able to eliminate it. This is what's known as an additive inverse, meaning that if you add them together, you get 0. So an inverse just means like it gives you the identity. For addition, the identity is 0. I don't stress the vocab too much. I didn't really use vocab until I started in higher level math, so I'm not expecting you guys to know it. I just expect you guys to know that you just have to eliminate by getting 0. From here, you can get the 5. After that, it's simple. You just grab this 5 and you can plug it into the first equation or the second one. Once again, they're choosing to do the first equation. You don't have to. That's just what they do. So the point where these two lines cross is here. So that's all we're doing. Don't forget what we're actually solving for. We're solving for the point where the two lines cross each other, where they meet. And by doing this, we're assuming that the lines are going to meet at the same spot. So that's why we do elimination. We try to make it look the same. That way we can figure out where these two combined are equal to each other. So let's look at here. So right here, we're looking at these two equations. They are probably going to either eliminate the 3. You can multiply this by -3, or eliminate the y. Since this is already negative, it's easy for us to just go like, hey, we're just going to multiply this bottom one by 4, and it makes it really easy to add. So that's what they're doing here. They just multiplied this by 4, and you can see here that they're explaining it. So all of these explain it very well. From here, what we're going to do is we're going to add them together. So we're going to add everything. They're adding, why are they adding 8? What are you doing here? Oh, I see what they're doing. They're just adding 8 to the top and the bottom. What is this? This is interesting. Are they solving this equivalent equations? Add 8 to both sides. I am not sure what they're trying to do here, guys. I'm sorry. This is not normally how you solve elimination. You would have just gotten 13. Oh, they're doing a bunch of weird stuff here. I see what they're doing. They're adding 18 to both sides, then they're adding this equation to both sides as well, which is just weird. I don't understand this step. I would ignore it. They're just using substitution, which to me, why are we using substitution? I think they're just making elimination a little more complicated than it has to be. You guys can watch that video if you would like. So this one's a little more complicated because look, you can't just multiply the top one by something and get a 4, or you can't multiply the top one and get a 5. So what we're going to do here is we're going to look for the lowest common multiple, meaning we have to either turn this 3 and this 4. The LCM of them would be 12 because it's 3, 6, 9, 12, 4, 8, 12. So the lowest common multiple is 12. Or, let me erase this. I didn't want to erase everything because I wanted to keep that LCM there. Or if we were doing it for the y's, let's say we do it for the y's, between 2 and 5, this is going to be a 10. So the LCM of these would be 10. So we have to choose, are we going to eliminate x or are we going to eliminate y? And we'll see right now what Edmentum chooses to eliminate. All right, so if we're doing this, we're going to multiply both sides by 4. And if we do that, we get these two new equations. So they're eliminating x. Notice they multiplied this by -3 because they want to just be able to add them. Usually what I do is I subtract, but this is a really good technique. I like this method. That way you know you're always adding. You want these two to be opposites. If this is positive 12, you want this to be negative 12. How do you get this to be negative 12? You're going to multiply by -3. You add these two together. You're going to end up with no x's, a -7, and a -28. From there, you just divide both sides by -7. You get y equals 4. Again, once we have this 4, we can plug it into any equation. They keep choosing to do the first equation. Again, you don't have to do the first equation. You can easily choose the second. I think they're just going for the first one just to make it easier. It even says in here, one of. That one of means either or. From there, you just solve for x, and now you know that your point, since your x is -1, your point is that. So let's move on to the next one. All right, so now let's solve for this one. So this one, if I'm looking at this, I can't really turn 2 into 3, but I can turn y into 2y. So what I'm going to do is I'm going to multiply everything here by positive 2, because it's already negative up here. So if it's negative there, I just want to multiply everything by positive 2. So when I rewrite these, the top stays the same, 3y minus 2y equals 0. But the bottom, I'm going to change that to be 4x, because I'm multiplying by 2. I was supposed to try to make it the same orange color, but that didn't work out. Plus 2y equals 14. So when I add these two together, these two cancel each other out because it's a positive 2 as well as a negative 2. And we get 7x equals 14. So now I'm going to divide both sides by 7, divide both sides by 7, and I get x equals 2. I'm going to erase all of this. Now I have x equals 2. And just to kind of prove my point, you can plug it into anyone. It's not just the first one. I'm just going to plug my x into the first equation. So I'm going to write 2. And instead of writing x, I'm going to write this other 2 that I got just solved for. And I'm going to do my plus y equals 7. So I get 4 plus y equals 7. So then this is supposed to be a 4. I know you can barely tell the difference between my y. If you subtract 4 from both sides, you get y equals 3. So therefore, my answer has to be the x value where these two lines meet is 2, and the y value where these two lines meet is 3. And that's how you get your answer. A little confused as to why this is not telling me how many slides there are. I was just looking at that. I know that's kind of like a random thought, but let's move on. So now we're solving problems with system of equations. And there's several of these, like if you're comparing train tickets to somewhere, or if you're doing chemistry and you're trying to figure out the percentage of certain chemical in there, there's a lot of things these types of equations can be used for. So the one that they're going to be used for here is comparing the price of an all-you-can-eat buffet. So because there's 120 people, choose the buffet. The first equation is this. So we're having two situations here. We're going to have adults and children. So we don't know how many adults, so we're going to say X represents the number of adults. That's right here. If you guys ever need help with that, you guys can always just highlight this just as a reminder. So X represents the number of adults. I like that. And then Y represents the number of children. So we're going to make that green. And then it costs $20 for an adult. So I'm going to use the same color, yellow, because we're talking about adults. And then a child, green, is that. So this helps me make the formula. So this top formula represents people. This bottom formula represents the money they got. They collected this much money total. So this is the total number of money. And the other one was number of people, because there's 100 and so many people. So this formula represents people, and this formula represents money. And that's usually a good way to kind of keep track of what everything means. Purple is money, purple is people, blue is money, green is for children. I'm starting to realize I should have save this for money. And yellow represents the number of adults. So anytime you see a green, that's what we're going to be doing here. So this is a good way of figuring out how people got, how many people were in the buffet. Now, when we're looking at chemistry, there's an acid that's 50%. So we're looking at a 50% solution. A 50% solution, I'm going to make it yellow, and then another solution only has 30%. And this percent. Okay, so we have a few things here. Acid. So a chemistry student, this is our goal. Oh, I see. The student needs that much. So this is our goal overall. So I'm just going to make this the blue, and I'm going to make this the yellow. Okay. And how many milliliters of that do you need for that? And he wants this much. So one of our equations represents literally just the amount of milliliters. The other one represents how much we have here. So this one's going to be the total solution. So that's going to be our blue. The reason why this is like a lot more than what it is we have to think, if we want 50 of this, 50%, and must mix to obtain the 50% solution, we're going to have to multiply this by the 50%. So that's 60. Where did they get the 150? Hang on here. The mix, X milliliters of that. That. So we're doing 60%. Okay. Equals 30, 50. They're doing this a lot more complicated than I would wish. Let me show you what I mean. The way you're supposed to do this, oh, I see what they're doing. Kind of. 0.3, 0.6, 0.50. The way they're doing this is we have this represents the number of milliliters, like I said. The blue, this is a little confusing. A lot of students struggle with this, and I can see why when they made this. What happens here is we're doing 30%. So 30%, let me use another color so not to make it confusing. When we're doing 30%, think of this as 0.3%. 0.3% of X plus 0.6, so 60% of Y is equal to 0.5 of 30 milliliters. We don't know how much X is, so we can't multiply it, but we do know how much of this 50 milliliter solution we want. Now, what they did is they got 1.5, but instead of doing decimals, they were like, why don't we just multiply this by 10 and that'll make it better. So, oops, and this is actually 15. I'm sorry. 15, not 1.5. I am totally going to have to erase that. So that's how they end up getting this. They don't want decimals, so they convert this to this. So in order to combine this, if you want to eliminate x, we're going to have to multiply this by -3. So this one's a little complicated because it does involve some multiplication, and with the decimals, it doesn't help. But we'll get through that. So let's take a look at this one. So we're going to write a first equation. So let's take a look at what we're talking about here. So a test is worth this many points. So our goal here is this many points is the total. 70 of the questions. It contains 7 questions. Oh, so let me remove these highlights. So we're going to be talking about 150 points. That's one of our goals. And 70 questions is our other goal. Some of the questions are worth 2 points. So these are the 2 point questions. These are going to be our X. Yellow is going to be our X because that's what we've been doing. And the other questions are going to be 4 points. So 4 points is going to be our Y. So in order to do this, we need to find an equation representing our total score. So they already did the first equation. They're like, there's X questions plus Y questions. Well, we're going to say X questions are the 2 point questions. So we're going to call this A. Oops. So in other words, they kind of already did our purple goal right here. Give me a second here. That's our purple equation. And we need to have another equation for our blue. Well, since it's our blue equation for points, we're going to do 150. And then we're going to do another equation. So not an equation. We're going to represent this variable, the yellow. So this is our yellow right here. I don't think that works. I tried. And this one's going to be our blue. So that's how, or green. Sorry, I keep using the wrong color. That's our green. Submit that, and we get our first equation done. Next, we have to figure out how this works. So what I'm going to do here is I'm going to solve it. I have this x plus y equals 70. I'm going to eliminate the x because I don't want to multiply by too much. So I'm going to multiply by 2 here. And then after I rewrite everything, I get 2x plus 4y. Oh, let me multiply this by negative 2. 2x plus 4y equals 150. So that one I literally just moved over. The other one I'm going to actually multiply. So I get negative 2x minus 2y equals negative 140. Add these up. The x's cancel. That was the whole point of what we were doing. We get 2y equals 10. So in other words, after I divide by 2, my y equals 5. So I'm going to do this. I'm going to put, and my y, if I remember correctly, y was the green. So the green is going to be 5. So 5 of the 4-point questions, because this is our green. Now I need to figure out my other questions. Well, luckily, since I know 5 of them are that, I can do x plus 5 equals 70. So after I subtract this out, I know x is equal to 65. So I'm going to do this, and this is 65. So again, I use the first equation for this one because it's really easy. You just have to subtract it. It's like, well, if you have 5 of the 4-point questions, all the other ones have to be the 2 points. So that's how you would solve this. And they even did the exact same way I did it. They're like, let's eliminate the x first. Self-evaluation. Easy when you only multiply one equation. So this is because it doesn't have LCM. LCM, I think, makes these equations a little tougher than they have to be. Not too bad if you're already familiar with LCM, but it can get difficult. Let's move on to the next one. So now we're going to be doing numbers of solutions. So numbers of solutions, an easy way to think about this is if you get an answer, one solution. If you try to eliminate something and you end up with something like 5 is equal to 5, meaning that your x's and your y's went away, you're dealing with a line on top of a line. Let's pretend I know how to draw. So that means that there are infinite number of solutions. If you end up with something like 0 equals 2, there's no solution. You should never get that. So these just represent like, hey, if you get an x and a y, you're good to go. They only cross one time. If you get something like 2, let me use a different color for this. So if you get something like 2 equals 2, then you get that. So just to kind of illustrate the blue one a little bit more, you'll end up with something like what we've been doing. X equals 2, y equals 5 after we replace them. And then the last situation, if we were to get that, would be something like, I wanted them all on the same page, but guess I don't get what I want. If you get something like that, 0 equals 2, there's no solution. That means these two lines are parallel. The x's and the y will connect, but what's happening is they have different x-intercepts. So that's why these two will never touch each other, because they're parallel. All right, so let's go into this. So here's the situation. We're going to add these two together. We get 3y equals 7, y equals 3. Plug it in here. We get that. So this has one solution. Nice and simple. Single solution. They're going to cross right there. Now let's do this one. So we're going to multiply this top one by -2 so we can cancel out those x's. But when we do this and we add it, we get 0 equals 0. That means these two are the same line. They just look a little different. They overlap each other. And our last situation, so we're going to multiply this one by -2 as well to eliminate this x. And we do that. And then we get this weird situation. We get 0 equals 1. That means that these two lines are parallel. So these are the examples of when we can have different solutions. So let's try to solve these. So what I'm going to do here is I'm going to eliminate the x by multiplying this by 3. So if I did this, I'm not going to do too much work because it's a lot of them here. So what I'm going to do here is I'm going to multiply everything by -3. So this is -3x, -6x, and this is -3. So if I add these two together, this cancels out, and this cancels out, and these cancel out. So I get 0 equals 0. So that means that this is the exact same line. I have the same number equal to itself. So I'm just going to move this over to infinitely many solutions. Now for this one, I'm going to multiply it by 2. That way I can just eliminate this y's, or actually -2, so I can eliminate the x's. But if I do that, notice how if I multiply by -2, it's going to also eliminate the y's. Because if I multiply this by -2, I get -2. That cancels out. This becomes, and this becomes +8. So these cancel out. And this becomes -14. So I have 0 equals 3. So that means there's no solution. 0 is never equal to 3. So there is no solution here. Cross that out. Now I'm going to try to eliminate this 2. So I'm going to multiply the top by -2. So I get -2, -20y, and -100. So x's cancel out. I get -10y equals -10. Y equals -1. Right off the back there, since I got a y equals something, I know this is one solution. This is good to go. All right, now I'm going to do it with this one. Okay, so these are pretty much okay. I just have to subtract. This is what I meant by sometimes you just have to subtract. If I distribute the negative, these cancel out. This becomes +2, so I get x, and this is 2. So I get x equals 2. So this one's good to go. This one, there's one solution. This is nice. I'm assuming these ones are going to be a little harder to do because it's a fraction, but at least it's one of the last two. And knowing Edmentum, they're not going to stack 3 as soon as I figure what this one out. I know I can do this one to make it easier, but I want you guys to see how simple it is to solve for this one. All I have to do is multiply this by -5, because guess what happens? This -5 would cancel out with this 5, so I get -2 on the top, which cancels out my y's. And the 5, this 5 would cancel out with this 5, so I get +3 on the top, +3x, so that cancels out that. and then I get -5 on the top. So everything cancels out, so I end up getting 0 equals 0. So since 0 equals 0, that means that this has infinitely many solutions. Meaning that if I did this one, odds are it's only going to have one solution. Did I do this one right? Hold on. Oh, derp. I was like, wait a minute, this was supposed to have one solution because it became x equals something. Okay, so I kind of mixed these two up. I'm sorry. Incorrect. Okay, apparently I mixed up more than I had to. So let me do this. I'm going to do this in my head because I think I just mixed the one solution and the no solution. If I multiply this by -3, these cancel, these cancel, these cancel, I get 0 equals 0. They're the same line. If I multiply this by -2, these cancel, I'm left with one thing. So this is no solution. That might have been where I messed up because I always feel it's one solution, no solution, infinitely many, but they're going the other way on this one. So I'm sorry. I did the work right. I just kind of messed this part up. So this one here, I multiplied it by -5. These cancel, these cancel, these cancel. So it's the same line. So it's infinitely many. This one I'm going to multiply by -2. These cancel, these do not. So this is one solution. This one, if I do this, I'm going to multiply by a negative. Makes this positive. So this is also one solution. And this should go here. So I think I just placed them in the... I did the work, but I placed them in the wrong spot. I'm sorry. Let's go here. Part of the disadvantage of doing this as one recording instead of editing it. All right. And then our summary. So again, always watch the summary video. I'm not going to play it because you guys have to go through this slide anyway. So watch it. It really helps for studying. And as always, do the practice as many times as possible. It's going to help you out for the mastery test. So looking forward for the next one, guys.